Hi everybody, Mr. Piercy here with part 2 of the measuring segments videos. This will be the last video talking about this stuff, and just to briefly cover what we went over in the previous video. We were talking about the ruler postulate, where we find the absolute value difference between coordinates on a number line to determine the distance between them, and distance is always a positive number. That's why we do the absolute value difference. And we talked about the segment addition and how algebra is used when we're talking about segment addition. Well, carrying on from segment addition, what we're looking at now is talking about midpoint of a segment. Now, the definition of midpoint is fairly basic. It just is the middle of a line segment. The name midpoint is fairly self-explanatory in and of itself. Anything that you're seeing in that first, what you're seeing in that first box up top, where it's talking about midpoint, it does have a line segment going through the segment AC. It has line L going through segment AC. Anytime you have a line or a line segment or a ray going through a midpoint of another line segment, we would call that a segment bisector. Now, that's not to say that it has to be a perpendicular bisector, which a lot of students misconstrue. If I say, give me a segment bisector of something, almost everybody has a tendency to want to make it perpendicular. It doesn't need to be, unless it specifies make it perpendicular bisector. And what you see in the box below, we're talking about midpoint. Now, midpoint is going to be something that we'll be spending a good amount of time on a little bit later on. But we are going to look at it here because we do have coordinates for point A and B, and so the midpoint must also have a coordinate. Therefore, there must be a math approach that we can take in order to find them. And what you're seeing is the formula here that I know it's so hard to see, so I'll just go ahead and write it out here. It helps if I have a pen selected. The midpoint is equal to the average, really, of whatever the two coordinates are. So let's take a look and see how we're going to use the formula. So in the first example, it says segment AB has endpoints -4 and 9, and what is the midpoint? Now, this one is fairly easy because it's on a number line. We could count it quite easily, but that's not the point. I do want to go ahead and use the formula, because that's what you will be expected to do, is utilize the formula to tell me what the midpoint of something is. So I'm going to use a capital M to represent midpoint. Remember, a lowercase m from algebra would tell me the slope of a line. So here I'm going to start by writing the formula. One of the things I will ask you to do in geometry, because there are so many of them, is that anytime you need to use a formula, I'm going to ask that you write the formula first. So the midpoint in this case is the coordinates for A plus B divided by 2. So substituting the formula, the numbers of our coordinates here, I have -4 plus 9 divided by 2. Okay, so -4 plus 9 in the numerator of the fraction is going to give me 5/2, or you could write it as decimal 2.5, not 2.2. And I would be satisfied with either version of the answer, either the fraction or the decimal, since they are equivalent numbers to each other. So this time, what I want you guys to do is pause the video and try the second example. Substitute the numbers and see what you get in your formula for the midpoint of segment JK. Now, at this point, I guess I'm assuming we're going to, you've already worked it out, so I'm going to go ahead and put my work down and see how you did. So here we're talking about J plus K over 2 for the midpoint. So I'm going to say 4 plus -12 divided by 2. Well, 4 plus -12 will give me a -8 divided by 2. So the coordinate for the midpoint of segment JK must be a -4. Now again, as we go over any of these examples throughout the lesson, if there's something you're not sure about, or if there's a thought you want to maybe clarify, make sure you're writing these things down as we go. Now, the example that you saw for midpoint using the formula, like I said, it will be coming into play later on down the road when we're looking at segments or lines on a coordinate grid where we have two coordinates for x and y. A lot of times what we're going to be looking at for segments, however, is utilizing the idea of midpoint to set up and solve an algebraic equation based on it. Now, I will let you know that in my experience teaching, what I see kids do a lot is uh, when we do segment addition, kids pick it up and do pretty well on it. And if I do just algebra with midpoint, kids will do pretty well with it. But when I start blending the two together, where you don't know if one problem is necessarily going to be midpoint or one problem is just going to be segment addition, students kind of don't necessarily pay attention to what the problem is asking them to do. So keep in mind, if we're talking about segment addition, you will have a third value of some kind to say this segment plus this segment equals another segment. But what students have a tendency to do in an example like I'm about to show you is they'll want to say, oh, well, this segment plus this segment must equal the whole segment PR, but they don't know what PR is. And so they fall back to what they think is the most next likely answer, and they'll say, well, PR must be 180 degrees, which is not anywhere close to what we're talking about. We're not talking about angles of any kind. So please keep in mind what type of addition you're using or how you're going to set up a formula. If you're saying segment addition, we're going to say something plus something else equals this. Here in this case, because we're saying midpoint, midpoint by definition divides something into two equal parts. Therefore, what we would say, since Q is the midpoint of segment PR, then that tells me that PQ must be congruent to QR. And we can tell that. We don't have to be told that it's the midpoint. The little hash marks on the segments indicate that the two parts are congruent to each other. And so at this point, again, we're pretty much done with the geometry. And now we're going to just say, substitute the measures, the algebraic expressions for each measure of the segment. So I say 6x minus 7 must be equal to the other expression, 5x plus 1. And now we can solve like normal. Isolate your variable on one side of the equal sign. Most of the time I'm going to take the smaller variable and move it to the bigger variable. So here they cancel out, and now I'm left with 6 minus 5, which is 1x minus 7 to be equal to 1. And move the 7 over through addition, and here those cancel, and I get x is equal to 8. Now at this point, if you stop, unfortunately you're only going to get maybe a third of the credit of the question that is being asked, because the question is asking you to find the lengths of the three individual segments. So let's start off by finding segment PQ. Well, the measurement of segment PQ must be equal to the expression, whatever 6 times x minus 7 is. So I'm going to take my 8, substitute it for x, and I'll say 6 times 8 minus 7. And 6 times 8 is 48. 48 minus 7 says that that is 41 units long. And so now we're going to do QR. So looking at QR, the measurement of QR, again, is 5x plus 1. So we will substitute the 8 that we got for our answer, say 5 times 8 plus 1. 5 times 8 is 40. 40 plus 1 gives me 41 units again, which kind of makes sense because if the midpoint is Q, then those two segments really should be equal to each other. And then let's go ahead and take this grayish blue one here, PR. So the measurement of PR, I guess I could call it RP, but I'll go ahead and keep it the way it is. PR must be equal to whatever PQ is plus QR. So 41 plus 41 gives me 82 units for my overall answer. So those would be the three values that I would be looking for. If this was a quiz question or a test question, I would be looking for all of the work to justify these values. Now, here I have the exact same diagram that we saw a second ago, where it says Q is the midpoint of segment QR. Now, here it's where it says find X. Well, we've already established that X is 8. How do you know it's correct? So the purpose of this question is not asking you to really do any more math about it. In fact, I might not ask you to really do more math other than maybe find what the value of X is. The real question here is, how are you going to be able to explain to me that you have what you believe to be the correct answer? In geometry, we are going to be doing a lot of writing about math because we're trying to get you to be able to communicate your ideas and use appropriate math vocabulary in complete sentences. Now, inside the gray box that I have here on the screen is I have an answer that I typed up as what I feel is a pretty reasonable explanation of how I know my answer is correct. Okay, so before I show you my answer, I want you to pause the video and try to come up with your own answer. Again, keeping in mind the way a proper complete sentence needs to be written. Usually, at least this is the way I was taught it in English, a complete sentence will contain some kind of an element from the question that was asked. You'll use complete sentence and appropriate math vocabulary as best you can. So go ahead and pause the video, write your own reason how you know X is equal to 8 is the correct answer, and when you're ready, play the video again and see what my answer was. Okay, so hopefully you have an answer written down now. Here is my answer. This is not the only way that you could have written it, but here I'm saying I know X is 8 because when I substitute into the expression, they produce the same number, and since Q is the midpoint of PR, then PQ must equal QR. So again, this is just an example. Complete sentences and try to use some kind of an element of the question in your response. So here is the last, or second to last, example that we're going to be looking at. Here we're talking about how we are going to determine the coordinates of a point. Here I have a number line, and I know where the coordinate for point A is 6, the coordinate for B is 15, and I know that C, according to the problem, is 2/3 of the distance from point A to B. So how do we find out what the coordinate for C is? Well, there's a process that we're going to go through here. First thing I'm going to do is I need to know, well, how long is segment AB? Okay, once I know how long segment AB is, the next thing I'm going to do is, not multiply, I'm trying to abbreviate here. Since C is 2/3 of it, let's just do this. Find whatever 2/3 of AB is. And then the third thing that we are going to do is we'll say add the coordinate for A to whatever 2/3 of AB is. So we have to have all that information. Now, the first part, finding how long segment AB is, well, that's not super challenging because this is where we're using the ruler formula again, where we could take the absolute value difference of the two numbers, or you could just count. Well, how many is it from 6 to 15? Okay, and so from where am I at here? I'm not thinking one. From 6 to 18, 6 to 15, we have 9 units long. So that means that the measurement of AB is 9 units. So what is 2/3 of that? All right, well, 2/3 of AB is where I'm going to say 2/3 times 9. Now 3 goes into 9 3 times, so 2 times 3 gives me 2/3 of AB to be 6 units. And finally, now I can say A plus 2/3 of AB, and that will tell me where C is. So we can say is equal to C. So here I'm going to say 6 plus 6 to be equal to C. So the coordinate for C is 12. Now the last example that we have to look at is pretty similar. Same basic idea, except instead of saying 2/3, now we're saying 4/5 of the distance. So I'm going to follow the same process, but what I want you to do before I work it out is I want you to pause the video and try working this example out. See if you're able to get the example that I get, and if you did, fantastic. If not, maybe double check, ask any questions that you write them down and send me your questions. So go ahead and pause the video now and try to answer this question. Okay, so now that we're back, let's go ahead and see what we have here. Again, first thing I'm going to do, find how long AB is, which is no big deal because we can just count it on our number line or take the absolute value difference of it. Here, now I'm going to say find 4/5 of AB, and then 3, again I'm going to say A plus, in this case, 4/5 AB to give me C. So first part here, the measurement of AB from a -4 to a +4 is 8 units long. Second, now I'm going to say what is 4/5 of AB? Well, that will give me 4/5 times 8. Now in this case, the 8 and the 5 in the denominator, they don't have like a common multiple. We can't simplify those. So we're going to just have to multiply straight, and we'll say 32/8. Or as a mixed fraction, you could say 6 2/5. If you want to write it as a decimal, you're welcome to. But sometimes decimals, or sometimes the decimal numbers that you get aren't very nice, meaning that maybe it's an irrational number where it doesn't stop and it doesn't repeat, or even if it does repeat, like 0.333333 forever, we don't want to round those. So it's much better to keep something in fraction form. 1/3 is considered an exact value, whereas 0.333 repeating, you have to stop it at some point. So at that point, when we have to do more math with it, it's no longer considered an exact number. So we're going to say 32/8 here, and then finally, I'm going to say 32/8 simply because I generally would rather do math with an improper fraction than a mixed fraction. So now I'm going to say A plus whatever 4/5 AB was, and A in this case is -4 plus 32/8. So now we need to have a common denominator. Oops, I don't know why I'm saying 32/8. I hope somebody caught me on that and said, hey, Mr. Piercy, you made a mistake. All right, if you wrote that down on your paper, that needs to be a 5, not an 8. Okay, so now we have to have a common denominator. So I'm going to multiply the -4 top and bottom, because remember, -4 is really -4/1. Multiply that by 5, and that will give me -20/5 plus 32/5, which would give me 12/5 as the coordinate for C, or 2 2/5, or I believe that would just be 2.4. Any version of those would be fine because they're all equivalent to each other. So that's going to call it quits for segment stuff, how we're going to be measuring segments. Now, we're not done with segments by any means. This is just the introduction of how we're going to be doing this. Segment addition, identifying midpoints, and determining lengths of segments because of midpoints. This idea of addition, taking two parts, adding them together to make a bigger part, will be carried over into angles and some other concepts that we'll be studying over the course of the year. So as always, if you have any questions from this lesson, make sure you have them written down and send them to me at your earliest convenience. And until next time, guys, thanks for watching.